Hello, everyone, and welcome to today's webinar, Innovative Storage Techniques for Lyophilized Laboratory Samples. I'm Cassie Soltman of LabRoots, and I'll be your moderator for today's event. Today's educational web seminar is presented by LabRoots and brought to you by LabConco. To learn more, visit www.labconco.com. I'd like to now welcome our speakers, Zachary Zakaib, Product Manager for LabConco, and Jeff Madden, Vertical Marketing Manager for LabConco. Zachary, you may now begin your portion of the presentation.
Hello, everyone, and thank you for joining this presentation. Just to give everyone a rundown of what we'll be covering today, we're going to start with lyophilization and the science behind it. We'll move into some of the products that utilize lyophilization, as well as some of the emerging research areas that are involving odd sample requirements. Then we're going to talk about lyophilizing and sealing under vacuum, which we believe is a good solution for a lot of these emerging problems. Then we're going to transition into traditional methods of lyophilized sample storage, as well as how you can adapt those methods to a smaller scale within your lab. Then we're going to finish up with aseptic sample processing and some of the resources that we offer at LabConco to help you guys figure out how to process and store your lyophilized samples. Just so we're all on the same page, lyophilization is another term used to describe freeze drying, and this process is meant to remove moisture from samples by way of low pressure and low temperature. This not only preserves the nutritional and structural aspects of the sample, but it can also allow for long-term storage under ambient conditions, which is incredibly important in a lab setting. If you've ever seen dry ice at room temperature, you've seen sublimation in action. As the dry ice takes on heat energy, it produces a vapor rather than melting into a liquid. Freeze drying works in a very similar way by reducing the pressure around a frozen material, allowing the frozen water to sublimate directly from solid phase to gas phase. It preserves the sample integrity while gently removing moisture. On the left-hand side of the screen, we can see a phase diagram for water. If we start in the middle of the diagram, our water is in a liquid state. We can begin the process of lyophilization by pre-freezing our sample, taking it from a liquid to a solid. We then reduce the pressure in our chamber and add heat energy to enter the primary drying stage. This will remove most of the moisture, but not all. So we can then increase the amount of heat energy in the sample and continue the drying process until the correct amount of moisture is removed. But what happens to the molecules as they're being removed from our sample? That's where our collector comes into play. The collector is typically 10 to 15 degrees colder than our sample, pulling moisture out of the chamber and allowing it to freeze to the surface of our collector coil. This is also how we can collect and analyze whatever was removed from our sample. You're probably very familiar with lyophilized materials in your everyday life. We have more of our common materials, so everything from the freeze-dried coffee that you drank this morning to the strawberries in your cereal. We have astronaut ice cream. If you've ever been to a gift shop, you've probably seen astronaut ice cream there, and that is processed through lyophilization. You'll see materials that are a little bit more specific. So for example, bone fragments or tissue analysis, MREs for the military, and certain medications that are being produced through freeze drying. Freeze drying can also even be used for restoration and archival work in museums, which I'll talk about a little bit later. But by far, the largest use for lyophilization is pharmaceuticals. Because there's so much research in that area, workflows and equipment are often optimized for very specific small samples like vaccines. However, as science continues to evolve, so too do the types of samples being processed, and many times they don't conform to typical processing workflows. Many emerging areas of research involve samples that are too large to process in the serum vials common in pharmaceutical research, but they could still benefit from lyophilization and proper storage. An example of this is biological sample processing. Traditional methods of processing human and animal tissues require a fixative like formalin or continuous storage in an ultra-low freezer, both of which take up valuable time and resources to maintain. Lyophilization can ensure that these tissues can be preserved for easy storage in ambient conditions. Similarly, we're seeing lyophilization being used more in food and beverage research. If you see a product on the shelf of your local grocery store, there's a good chance that it was lyophilized at some point in the research, production, or packaging process.
You know, Zach, here at Lab Conco, we keep a pretty close eye on different markets, as you were saying, just to ensure that we know what the needs are or emerging needs are. And I would say, you know, going with your comment about the food market, we're seeing tremendous growth in food and beverage, especially, and it's not just the human food, but also pet food. We're getting a lot of interest from that industry. It's definitely a growth industry that we're seeing, as well as some of our partners in the distribution network have seen. So we're always trying to think of how can we help the scientists that are in this space and create solutions that will help them with their needs.
We've seen quite a bit of development in the field of biomaterial engineering as well, where the production of cell scaffolds and hydrogels require the use of a lyophilizer. Freeze-drying these materials and sealing them for storage can increase workflow efficiency and ensure these materials are more readily available when they need to be used. Lyophilization also plays a large role in artifact preservation because it can provide a gentle process that avoids the damage, distortion, and collapse risks present in other methods. For example, a lot of museums use lyophilization to preserve archaeological artifacts made of wood, paper, or other porous materials. By using a lyophilizer, they can gently draw out the moisture and ensure that that artifact is going to be available for ages to come. Microplates can be preserved using this technique as well. Oftentimes, these types of materials are prepped just before an experiment. It takes quite a bit of time to ensure that you're doing it correctly. You have to have your checks and balances in place, and if something goes wrong down the line, it's very hard to go backwards due to tighter flow or just the materials available. However, we're seeing emerging techniques using freeze dryers to create a stock of ready-to-use plates so that in this process they can just be taken off of a shelf rather than going through the entire workflow every time you want to do an experiment. We're also seeing printed circuit boards being used within lyophilizers. Printed circuit boards are hygroscopic, which means they absorb moisture from their surrounding environment. And lyophilization can be used as a tool to dry components just before final processing. These are especially important in printed circuit boards that are designed for use in cold temperatures as well.
You know, this is an interesting market. We're seeing tremendous growth, especially in the industrial sector. And I think a lot of it has to do with battery science advancements, the circuit boards that Zach's just talked about, and microelectronics and that. The recent reports that we've seen as of just a couple of days ago is that some markets are seeing a 21% growth in this area. So this is something that we're definitely keeping an eye on. We're trying to find ways to help the market in this space and to do as much as we can to help. You know, recently Frost & Sullivan conducted a global survey, and what they found is that for lab scientists, one of the driving needs that they have is for a more efficient process. And those are some other areas that we're definitely paying attention to in terms of what we can do to drive efficiency in the lab.
With a need for increased efficiency in workflows and the ability to freeze dry certain large, bulky, odd items, we've really focused on making our freeze dryers and accessories as applicable to a wide range of science as possible. Our answer to this is the LifeSeal Tray Dryer, which is designed to provide a solution for lyophilizing and sealing large non-traditional samples under vacuum. We do this through the use of zipper sealing bags. They can stay with the sample throughout freezing, lyophilization, and storage. This means that if you have a requirement to lyophilize and seal your samples, it can now happen all in one device. A typical workflow using the LifeSeal Tray Dryer would start with freezing your samples inside of our LifeSeal bags and clipping them into place on one of our heated shelves. From there, you would go through a traditional lyophilization process and end the run by sealing the bags under vacuum. Once you release the vacuum and remove your bags, they can then be heat sealed as a secondary form of protection and stored wherever you might need them. But maybe you're processing samples that can be handled in more traditional ways. On the left, we have ampule storage, which is an older technique, but it's still used in many labs all over the world. And on the right, you'll see serum vials, which are more popular in modern pharmaceuticals or labs that have processing abilities already. These methods both present drawbacks that make them difficult to work with in a lab environment. Let's start with ampules. Ampules are great for completely isolating your sample, but the amount of time and energy needed to process each container often leads to inefficient workflows. Ampules need to be flame sealed, which can be costly and time consuming in a lab environment. Furthermore, these containers need to be broken to provide access to your sample, risking contamination and injury to members of the lab if it isn't done correctly. Serum vials, on the other hand, are processed with a rubber stopper and an aluminum seal to provide sample containment. Samples are placed inside of the glass serum vials, and the split stoppers are halfway introduced into the opening of the vial. This leaves room for vapors to exit just before finishing the lyophilization cycle. From there, the stoppering capabilities of the freeze dryer will push the stopper down into the serum vial, sealing it under vacuum and allowing the researcher to place an aluminum seal to hold everything in place. The drawback of serum vial processing is that many of the commercially available devices for processing these types of samples are very large and very expensive. Here I have a picture of a typical pharmaceutical setup for processing these vials. But what happens when I'm trying to seal my lyophilized samples in a smaller lab setting? Is there a more affordable or compact option available? Two medium-sized solutions that we have for processing sample vials are a stoppering tray dryer or an all-in-one unit. Both models support vial pre-freezing, lyophilization, and stoppering all in the same unit. However, the model on the left sits on top of a large console freeze dryer, whereas the triad unit on the right is an all-in-one processing chamber and freeze dryer combination. What if this is still too large for my research needs, though? Well, we have even more compact options available for traditional sample preservation. On the left, we have our clear stoppering chamber, which sits atop our console or benchtop units and allows you to manually close your stoppering vials just after lyophilization is complete. On the right, we have an even smaller solution to our clear stoppering chamber called the mini stoppering chamber, which allows you to process a handful of vials at a time and is easy to store when you're not using the device. Finally, if you're looking to do more of a traditional ampule-style freeze drying and preservation, we do offer an ampule adapter that fits into the manifolds of our freeze dryers and can be used for lyophilization and flame sealing aseptic conditions if it's required by the lab. We do this by using our aseptic adapter, which fits into our flasks. It can fit on the end of our mini stoppering chamber, and there's a wide variety of uses that allow you to isolate your samples from the outside environment, protect the environment from your samples, or both. So if you're ever confused about how you might be able to preserve your specific samples, we offer a wide range of resources. Our freeze dryer configurator can get you headed in the right direction by showing what devices would work well for certain applications. We offer a wide range of white papers and articles to help with some specific applications. And finally, you're always free to contact us through phone or live chat. We're more than happy to sit down and talk you through your application and processing needs. So with that, thank you for tuning into this presentation, and I hope it helps shed some light on the options available for preserving your lyophilized samples. Thank you.
Thank you, Zachary and Jeff, for your informative presentations. We will now start the live Q&A portion of the webinar. Let's go ahead and get started. Our first question here asks, can I send a sample to test before we decide to purchase something like this?
And I can take that. Actually, I'm Zach, by the way, just in case it's not coming up on who's speaking. So here at LabConco, we see everything come through the doors. We get a lot of companies who are wanting to see if maybe grains can be tested in these, or certain animal tissues, or just last week we did a waterlogged Bible for some demo lab purposes. So if you ever do have a sample that you want to test and it is safe for us to bring it in the building, we're more than happy to go through that process, test it on whatever equipment you might want to purchase or look into, and then come back with data and back and forth to make sure that whatever we are providing to you is going to work for the science that you're doing.
Excellent. Thank you, Zach. All right, our next question here asks, what size and material are the bags used in the LifeSeal tray dryer?
Yeah, for the LifeSeal freezer bags, or I guess storage bags, they are a double-walled polyethylene material. We decided to go with that just because it's the most compatible with a wide range. It's also widely available. The size of the bags, currently we're offering them in a 6-inch wide by 9-inch tall version. And then we're looking into making a 4-inch wide version as well, just so that you can fit more bags onto each tray of the tray dryer. So each tray currently holds 2. We're looking into methods to shrink those bags a little bit, offer a secondary version that you can store 3 to a shelf. The 6-inch versions do hold things like micro plates, just in case anybody was wondering about that.
Fantastic, thank you. These are great questions, so keep sending them in. It looks like we have one more here in the queue for our Q&A today. That question says, good day, is it necessary to store freeze-dried biological materials at -20 degrees Celsius, or can it be possible to store at from 2 to 8 degrees Celsius?
Yeah, so a lot of biological materials can be stored at ambient. It kind of depends on what you're working with. So for things like bacterial or fungal cultures, those can normally be stored at ambient temperatures afterwards. For more sensitive things, you can store them either in ambient conditions or in just a normal lab refrigerator, which makes freeze drying and lyophilizing incredible for your samples. It means that you won't need to keep them at a low temperature like -20. You can store them in just commercially available refrigerators.
Excellent. Thank you so much, Zach. It looks like those are the questions that we have today. Before we go, I wanted to ask, did either of you have any final comments you wanted to make for the audience?
Thank you for tuning in. First of all, it was great to talk about all of these different ways to store lyophilized samples. One of the great things that we offer at LabConco is just expert care and the ability to ask questions. So please feel free to reach out if anybody has any questions about the products or the processes or the science that you're doing. We have a staff of people available who love to talk about science, love to talk about how we can improve laboratory workflows. So please feel free to reach out. Our hours are posted on our website for our phones, but we're always available through email as well. Jeff, do you have anything?
Wonderful.
No, we appreciate everyone's time. I think this was hopefully a helpful topic for everyone, and appreciate everyone tuning in.
Thank you again, Zachary and Jeff, for your time today and your important research. We would also like to thank LabRoots and our sponsor, LabConco, for underwriting today's educational webcast. Before we go, I'd like to thank our audience for joining us today and for their interesting questions. Until next time, take care, everyone. Goodbye.